One of the most common actions performed in VIA is taking objects, moving, rotating and throwing them. So one of the usual actions to a program in VIA development is a consistent way to deal with that kind of interactions. I have been working with Unity for years, developing video games and VIA applications, and I have tried many different ways to grab objects. I am going to explain them with pros and cons. Before explaining my recently discovered new approach, the first idea that comes to your mind if you have been developing with Unity3D before could be this one. When grabbing an object, make it child of player's hand, and set a task kinematic. That works perfectly. The object follows hand's position and rotation smoothly, but it has an inconvenient. Kinematic rigid bodies only detect collisions with rigid body colliders, as the following table shows. Table from
https://Unity3D.
Manual colliders overview.
HTML.
Rigid bodies are bought for performance. They are supposed to be used to simulate physics, and with that in mind, they should be used only for that. So we should use rigid bodies for that objects player can grab and throw, but not for walls and other static objects. Of course, you can set the object non-kinematic, but it will make it move on player's hand on every collision. That can be fun for a casual experience, but it is nonsense for a real, serious game experience. Imagine using a sword in VIA that stagger on every hit ending with the sword pointing backwards in player's hand. But do we really need collisions with static colliders and other kinematic rigid bodies? Well, it depends. Maybe you do not need it. If that is your case, that approach is okay for you. But I like to improve my experiences games with details, like some spark particles on a stone wall, when player hit it with a metallic weapon with enough force. If you feel you would like to improve your game's VIA experiences, keep reading. From Unity's manual, fixed joint restricts an object's movement to be dependent upon another object. This is somewhat similar to operating but is implemented through physics. Rather THNT-array NSF-array The best scenarios for using them are when you have objects that you want to easily break apart from each other, or connect to objects' movement without parenting. That way, you can add a fixed joint component to grab objects, and when grabbing it set connected body public variable of fixed joint component to the hand. The problem here is that hands need a rigid body component, and even worse, fixed joint physics fight all the time with the object simulated physics, and that causes some weird behavior. From Unity's manual, a constraint component links the position, rotation, or scale of object, the fundamental object in Unity scenes, which can represent characters, props, scenery, cameras, waypoints, and more. A game object's functionality is defined by the components attached to it. More info, see in Glossary to Unity3D object. A constrained game object moves, rotates, or scales like the game object is linked to. I found that some maths ago, and I thought it could be the correct way to solve my problem with object grabbing. Specifically, I tried with parent constraint. That is what Unity's manual says about it. A parent constraint moves and rotates object as if it is the child of an Unity3D object and the hierarchy window. However, it offers certain advantages that are not possible when you make only a object parent of another. A parent constraint does not affect scale. A parent constraint can link to multiple game objects. A game object does not have to be a child of the game objects that the parent constraint links to. You can vary the effect of the constraint by specifying a weight, as well as weights for each of its or stable objects. For example, to place a sword in the hand of a character, add a parent constraint component to the sword game object. In that sources list of the parent constraint, link to the character's hand. This way, the movement of the sword is constrained to the position and rotation of the hand. With that example, what could be wrong? I tried it with, apparently, success. It works more or less like fixed points, but without physics-tricky things. I tried to write my own code to copy position and rotation of player as hand to grabbed object before, and it did not work at all. I think constraints work that way, but they are unable to execute it in the correct precise moment they need to, because they are part of the engine. The problem: constraints are so much better than fixed points, but it seems like they find rigid body physics to undo bumping frame. By frame I realized that objects collided were jumping to strange positions sometimes after a collision. That triggered false collisions around the player, and it was so annoying. Before explaining my recent discovery, I would like to point out that there are a lot of plugins that make a developer's life better. On Unity asset style you can find them. I do not know if they solve this problem, but if you want to work quickly and you do not mind to work try to others code architecture, you can try. Recently, I have tried to use track and pose a driver component, the same I use to make game camera and hands follow the headset and controllers, to grab objects in Unity. When player grabs an object, that is what happens to it. What that code do? The simplification of my code. I'd use offsets to grab objects in different ways, but here it uses hand rotation and position of pose provider. It is important to say that best pose provider is experimental and it can't change. It will migrate from Unity3D. Experimental. XR. Interaction for sure. With that new approach, all seems to work perfectly. With collisions with walls and other static colliders, and without strange physics simulations. I do not know if this is the best approach for grabbing objects in VR with Unity3D at this moment, but this is the best I have been able to figure out. I will keep investigating and trying new things to improve my skills and my games. I hope you have found this post useful. If you have any question, do not hesitate to ask here. I'll sending an email to your email protected. Thank you for your time. Before starting production on Note only, we took some time to prototype various typing gameplay ideas. When prototyping, you have to focus on the things you want to test, and iterate on them as fast as possible. There is no time to document everything. But the prototypes do not always speak by themselves. Sometimes there is no playable build to keep, like the time I tested interactive dialogues. By acting as the append, talking through Slack with a colleague. We will get back to that. So we needed a way to archive what we learned from each iteration, in a format that would be quick to write and read. This is a common problem of design documentation. How to keep an account of the decisions that led to a design. As it is interesting to keep a trace of previous iterations, to look back at the evolution of a design. But more importantly, it is a waste of time if another designer, or your forgetful self, makes changes that recreate a problem that has already been solved, just because they have no knowledge of the history behind that decision. For all those reasons, I was looking for a practical way to link each feature to the decision path that led to it. It needed to be quick to write and to read. Because if we have to go back and read multiple paragraphs of history, we all know no one will do it. Surely, someone already came up with a solution. Right. Sadly, I could not find anything related to game design. The results I found were tools to keep track of programming design decisions in code, as it seems programmers need a similar solution for similar reasons. Eventually, I found a research paper about an experimental tool made to present design decision-making in a simple way. It gathers decision elements from different sources, code annotations,